Four resistors are connected to a battery with terminal voltage of 12 volts as shown in figure 2044, which is this figure that we drew here. Determine the following. So first we're going to start with A. A tells us to find the equivalent resistance for the circuit. So first what we're going to do is we have our circuit here, and what we're going to do is we're going to simplify it. So first, because this is your simplest circuit, we're going to combine those to get 80, and what you do is you just add those. And now we know that here we are going to, these two are parallel, so we're going to combine those. And when you combine those, you use the resistance formula seen down here. And once you do that, you're going to get 42.4. And so then what you're going to do, because this is in series, you're going to combine these two, and when you add it, you get 62.4. So your answer for part A should be 62.4. The next part, part B, asks for the current in the battery. So our work for that is down here, and all you're going to do is use the formula I equals V over R. And you know V is equal to 12 volts, while R is 62.4, which is what we found in the previous part. So you do 12 over 62.4, and you get 0.192 amps. Now for part C, it is asking for the current in the 30 ohms resistor. So our work for that is right below here. So what you can do is, if you look at our simplified diagram, you have the 80 here, and then you have this one here. So what you can do is you can find the current for 80, and then find the current for 50, and then subtract it to get the current for 30, because you know that the currents should add up. So we have I over VR, which is equal to 12 over 80, which gives you 0.15. And then you also have I equals V over R, which equals 12 over 50, which equals 0.24. And when you subtract it, you get 0.09. However, you're going to have to take that and subtract it from the entire current of the circuit in order to get your current for just the 30 ohms. So when you subtract the two, you do 0.192 minus 0.09, and you get 0.102. So your answer for C should be 0.102 amps. Now we're going to move on to D. D is asking for the power dissipated by the 50 ohms resistor. Now here you're just going to use the power formula, P equals IV. So you know that I equals 0.02 amps, which we found in the last part, and you know that V equals 5.1 because we calculated it for it right here. So V equals IR, and when you multiply I and R, 0.02 times 50, you get 5.1. So you just multiply the two using the power formula, and you get 0.52 watts. Now E is basically the same thing. You use the power formula, P equals IV, and here what you have to do is you have to calculate for the voltage. So you have I, which is equal to 0.192, and R, which is 20, because you're looking for the power dissipated by the 20 ohms resistor, and when you multiply the two, you get V equals 3.84. Now you take the voltage and you use it in the power formula, and so you multiply it and you get 0.192 amps times 3.84 volts, and your final answer should be 0.737 watts.
Thanks for listening. Bye-bye.